Hello everyone, welcome back to Quantum Science Hub. In this video, we will discuss Chapter 5 of IGCSE Chemistry, Chemical Energetics, which focus on exothermic and endothermic reaction based on the latest IGCSE syllabus. So, let's get started. First of all, let's talk about exothermic reactions. Exothermic reactions release or given out thermal energy to the surroundings, leading to an increase in the temperature of the surroundings. The transfer of thermal energy during a reaction is called the enthalpy change. So this is the symbol delta H of the reaction. Delta H is negative for exothermic reaction. So please remember, for exothermic reaction, the sign for delta H is negative. The common example of exothermic reactions like combustion. Combustion means you burn something. Oxidation. Next, neutralization. So this is exothermic reaction. Okay? The delta H is negative and heat is released or given out, so the temperature of the surroundings will increase. So these are the three things that you have to remember. Okay? Next, let's see the exothermic energy diagram. Okay, so this is the exothermic energy profile diagram. So remember, for exothermic, it starts from the middle and then you go up and then you go down. So the reactants is in the middle while the product is at the bottom. Please remember, so that means the reactants have more energy than the product because the reactants, the position is in here while the product, the position is in here. The reactants is higher than the products. That means the reactants have more energy than the products. And this is EA. What is EA? Activation energy. What is activation energy? Activation energy is the minimum energy that colliding particles must have to react. And this is the delta H or the enthalpy change for exothermic. Well, it looks like this energy profile diagram is quite simple and easy, right? But please remember, one of the most common mistakes the students make while doing this energy profile diagram is they put the double arrowhead. For example, EA, they put the arrowhead in here and they also put it in here. So if you put double arrowhead, you will get -1. You cannot get full mark. The same thing with the delta H. The delta H is negative, so the arrowhead must be pointed down. You cannot put the double arrowhead up and down. So make sure the energy profile diagram is exactly 100% like this. So the arrowhead for EA or activation energy is always pointed up and it should be a single arrowhead. And for exothermic, the delta H arrowhead should be at the bottom. And again, it should be a single arrowhead. Don't forget to name the reactants in here. And this is the product. Okay? That's all. Now let's talk about endothermic reactions. Endothermic reactions takes in or absorb thermal energy from the surroundings, leading to a decrease in the temperature of the surroundings. Delta H is positive for endothermic reactions. And the common example of endothermic reactions like electrolysis, thermal decomposition, and the first stage of photosynthesis. And this is the example of endothermic reaction. So there are three things that you have to remember. First, endothermic reaction takes in or absorb energy. As the result, the surrounding temperature will decrease. And the last one, the delta H is positive. Now let's see the endothermic energy diagram. So this is the energy profile diagram of endothermic reaction. So it starts from the bottom, go up and finish at the middle. So this is the reactants and this is the product. EA, its mean is from the reactants to the top. So this is activation energy, right? While the delta H is the difference between reactants and the product. So the reactants is in here, while the products is in here. And the delta H of endothermic reaction is positive, and that's why the arrowhead should be pointed up. Again, you cannot draw double arrow up and down. It should be single arrow. For activation energy, it always pointed up, right? while the delta H is depend on the reaction. If exothermic, the arrowhead should be pointed down, while endothermic should be pointed up. And don't forget to name the reactants in here and the products in here. Now let's talk about bond energy. What is bond energy? Bond energy is the amount of energy required to break 1 mole of a particular covalent bond in gaseous molecules. Okay, it should be in gaseous molecules. Bond breaking is always an endothermic process as energy needs to be taken in from the surroundings to break the chemical bonds, while bond making is always an exothermic process as energy is transferred to the surroundings as the new bond is formed. If more energy is released than is absorbed, then the reaction is exothermic. The change in the energy or delta H is negative since the products have less energy than the reactants. But if more energy is absorbed to break bonds than is released to form new bonds, this reaction is endothermic overall. The change in energy or delta H is positive since the products have more energy than the reactants. Now let's see the example diagram of bond energy. So I have a chemical bond in here. Let's say this is the molecules. So when the energy is in, you want to separate these two atoms because they have bond in here. Since the energy is taken in, so this is what we call bond breaking or endothermic. After they break, they will become a single atom or a single element, right? On the other hand, for example, I have a single atom or element in here and I want to change them into a molecules. So the energy is released and this is what we call bond making or exothermic reaction. And after that, they will change into a molecules and this is the bond. Okay? Now let's talk about bond energy calculation. How to calculate the bonding energy. So first, we write a balance equation. If it's not yet balanced, then you have to balance it first. Next, draw the displayed formula in order to identify the type and number of bonds more easily. So that means you have to open the full structural formula of the molecules to easily identify the number of bonds. Okay? Next, add together all the bonds energy for all the bonds in the reactants, and this is the energy in. Next, add together the bonds energy for all the bonds in the product. So this is the energy out. Energy out is mean it is in the product or at the right side. And calculate the enthalpy change with the formula enthalpy change delta H equals to the total energy taken in or the total energy at the reactants minus total energy given out or the total energy at the product. Or in a simple way, I can say delta HR, R here means reaction, equals to the sigma. Sigma here means the total, okay? The total energy at the reactants minus the sigma or the total energy at the product. Now let's see the word example 1. So we have the chemical reaction in here. H2 plus Cl2 will become 2HCl. And the bonding energy are given as, so this is the data for the bonding energy. And the question here is determine if the above reaction is exothermic or endothermic. Okay, how to solve this question? So let's open the displayed structural formula. Okay, H2 it means H and H, right? Cl2 is mean Cl with Cl will produce 2HCl. So a single HCl is mean H with Cl, but we have 2 HCl, so that's mean we have another HCl in here. Okay, based on the formula, delta HR or the enthalpy reaction equals to the sigma of the reactant minus the total energy bonding of the product. So equals to, at the reactant, it means at the left part we have H and H. And how many H and H? 1 time, right? So we write 1 times H and H plus 1 times Cl with Cl. And then minus with how many HCl in here at the right side? 2 HCl. So we write in here 2 times HCl. Now we just put all the number based on the bonding energy data that is given. H and H is 436. So plus 1 times Cl with Cl is 242 and minus 2 times HCl is 431. So you will have 678 minus 862 equals to negative 184 kilojoule per mole. Okay, so what is the meaning of kg in here? Kg here means kilojoule per mole. Remember, kilo means 1000, right? So 436 kilojoule is just the same with 436,000 joule per mole. Now the question is asking about if the above reaction is exothermic or endothermic. You can say the above reaction is exothermic because energy is released to the surroundings. Or you can also say this is because the enthalpy change, the delta H, is negative. Now let's see word example 2. Determine the enthalpy change for the following reaction. N2 plus 3H2 will produce 2NH3. The bonding energy are given as. So this is the data for the bonding energy. And how to solve this question? Like I told you before, first of all, you have to open the displayed full structural formula for the reaction. So we have N2 in here, so that means it is N triple bond with N, okay? And then plus H2, it means H with H, but we have 3 H2. So just draw like this and will produce NH3. So a single NH3, the structure is like this. So 1 nitrogen bonded to 3 hydrogen atom, right? But we have 2 NH3. So like this. Okay, now how to solve this question? Delta HR equals to sigma of the reactant minus sigma of the product. Okay, equals to, so at the reactant is mean at the left side. So how many N triple bond N? We have 1 times, right? So 1 times N triple bond N. And then plus with 3 times H and H. And then minus with, okay, so please take a look in here. How many N and H in 2 and H3? We have 1 bonding between N and H, 2, 3, 4, 5, and 6, right? So that means 6 times the bonding between N with H, nitrogen with hydrogen. Now just put all the value. So 1 times N triple bond N is 941 plus 3 times hydrogen with hydrogen is 436 minus 6 times 391. So equals to 941 plus 1308 minus 2346. So altogether equals to negative 97 kilojoule per mole. Okay, so this is the final answer. Now let's see the word example 3. This is the average bond energy given. The equation for the combustion can be shown using displayed formula. So this is the chemical reaction and calculate the enthalpy change for the combustion of methane. Okay, so how to solve this question? Again, based from the formula delta HR equals to, we just calculate how many carbon and hydrogen. So we have 1 carbon and hydrogen in here, 2, 3, 4, right? So 4 times carbon and hydrogen. And then plus 2 times O double bond O. And then minus with how many O double bond C? 1, 2, right? So 2 times C double bond O. And then plus how many in here? For a single H2O, so we have H and O, and we also have another H and O. But in here, this is 2 H2O, right? So we have 4 times the bonding between H and O, okay? Now just put all the information that is given equals to 4 times C and H is 412 plus 2 times O double bond O is 496 minus 2 times 743 and then plus 4 times 463. So equals to 1648 plus 992 minus 1486 plus 1852. So equals to 2640 minus 3338. So equals to the negative 698. Don't forget to put the unit, so it'll be kilojoule per mole. Okay? So yeah, that is how you solve this question. So that's all about this chapter, Chemical Energetics. We will discuss some past paper questions related to this topic in the next video. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.